Thank you very much for tuning in to my channel. So this will probably end up being a series of videos on the PIC 18F4525, and I'm excited because I just created an experimenter's platform for my new 40-pin microchip. Forgive me because I'm not going to go in depth into how to open up a new standalone project and get started. If you check out my PIC10F200 video series, which I've created, there's some pretty good coverage on how to go about doing that. So I basically just started a new project for my 18F4525. I will say that for setting up the configuration bits, there were only 3 things that I really changed from the default settings, and that was first to use the internal oscillator, this INTIO67, and then I scrolled over and I selected the internal oscillator port function on RA6 and RA7, or it's basically on RA6 and RA7. I set the watchdog timer to off, and the low voltage programming I also set to off. And that's the only thing I made changes to. I generated the source code. I didn't even create a separate header. I just put the configuration code right into the program, the main.c file, and just included it as the first 46 lines. Now I tried... where do I start? Oh, I had a moment of trouble where I was having some problems uploading the code to my microchip, and again it's one of those power issues. So I went to default, but then I went to the customize. Then you go to PIC-Kit 3 and select power and make sure that you are powering the target device from the PIC-Kit 3. Otherwise there's issues with uploading. I wanted to include that in this video because I forgot how to do that, and it seems to come up every time I use a new chip. This particular chip has an analog to digital converter, and the way it's configured in the data sheet is that the first 13 GPIO pins are configurable as analog or digital pins. And so this, without explaining, will just turn the ADC off, making all of the analog pins digital. Now, port A and a little bit of port B, 13 pins, can be configured as analog or digital. So anyway, this just turns the ADC off, and there is far more to explain technically what's going on, so I'm not fully explaining how that works. Also, there's the oscillator, and this has to be defined at 8 megahertz. I did that, and it worked for a certain code, but then I wanted to just flash an LED, and all of a sudden I had like oscillator error messages. I couldn't understand it, so then I added the frequency like this, and it seemed to take care of the problem. I could even demonstrate it on camera, taking this in and out of the program, and you can see the error messages, but I won't do that.
Okay, good morning. Once again, this video is just to kick things off. I don't know what direction things are going to go in, but I've built my experimenters platform, and I look forward to trying out some code. So I'll probably put this in a playlist with other videos, kind of like a series of videos. So thanks for watching. Have a good day.